Welcome to the World Space Week podcast for 2011.
I'm Elf.
And I'm Haritina Mogosanu, Manager of Educational Relations for World Space Week Association.
To celebrate World Space Week, we are putting together a series of podcasts to enthrall and excite everyone with the most inspiring space stories from across the globe.
Today we're featuring Dr. Chris McKay from NASA Ames. Dr. McKay, would you like to tell us a little bit about yourself?
I work at NASA at Ames Research Center, and my interest is in the search for life on other worlds, in particular the search for life on Mars. And I'm involved in research in environments on Earth where we try to find life growing in Mars-like environments. So I've been to New Zealand many times en route to Antarctica, where we study life that's growing in the dry, cold regions of Antarctica known as the dry valleys. We also go to dry deserts, the Atacama Desert in Chile, the driest desert on Earth, the Sahara, the biggest desert, and so on.
Dr. McKay, what is about the current progress in space exploration that makes us willing to celebrate the World Space Week?
Well, if we look back over the last decade, it's actually been pretty amazing, the progress we've made in space exploration, both in human exploration. The space station has been operating continuously as an international laboratory now for many, many years, almost, I think, 11 years. Planetary exploration has seen a whole variety of missions to Titan, orbiters around Saturn, missions to comets and asteroids, Mars missions. It's been a great time for planetary exploration. And in astronomy, the results from Hubble, from the various cosmology spacecraft, has been just amazing. If you look back, I think the last 10 or 15 years have just been astounding. The challenge now is keeping that momentum. The shuttle is retiring. There's issues with launching to space station. There's budget cuts looming, deficits looming. So the challenge before us is keeping that momentum and building on it. The good news, I see, the good news is how much more excitement there is in the general public for space exploration. An example is your show, for example. People are interested in this. And secondly, another bit I think of good news is the involvement of private companies like SpaceX and other companies who are going to try to get involved in the business of doing launches and hopefully broaden the access and push the costs down considerably. And that may be a big enabler in terms of the next decade in face of budget cuts to be able to implement that kind of approach. So I'm optimistic.
So you feel that there is reason for celebrating World Space Week after all?
Oh, definitely. Both in terms of what we've done, how much we collectively as humanity have done over the last decade, and where we might go in the future to build on that.
Excellent. So how is NASA celebrating Space Week? Are you doing anything strange or different or exciting?
Well, I don't know. They could very well be. There probably is an office at headquarters in charge of organizing this. And occasionally they call me up and say, can you show up at this event and talk? And I just say, yes. I don't really know very much about what's going on. I just do what they tell me to do. It's the usual excuse.
What about the Planetary Society?
The Planetary Society is a private organization, of course. It's a membership organization with members from all over the world. And their charter is to support space exploration and planetary exploration, and also the search for extraterrestrial intelligence. They support all of that. They have members. They collect input from members. They collect donations from members. They use that to lobby for activities that support space exploration. And I think more importantly or interestingly, they also fund small projects. So they fund equipment that goes on missions. For example, they funded the microphone that went on one of the Mars missions. And on the upcoming Russian mission, the Phobos sample return mission, Phobos Grunt, the Planetary Society funded a small capsule which will include microorganisms, which will fly to Phobos and fly back. And we'll see how they survive the round trip. So it's a very worthwhile organization for both activity and advocacy in space exploration.
We're living in very interesting times.
Incredible.
Yes, and you mentioned the Mars rovers. Have they found any evidence of possible life on Mars?
Not yet. The rovers that we've got on Mars now are mostly looking at rocks. The next rover that will go to Mars, the Mars Science Laboratory, also known as the Curiosity rover, will have the capability to look at organics as well. So we'll be able to, we won't directly be able to detect life, but we'll go one step beyond rocks. We'll be able to search for organic material. And I think I'm involved in that mission, and my particular interest in that mission is indeed the search for organic material. And for a variety of reasons, I'm pretty sure we're going to find organic material. So I would expect that a year from now, September 2012, we'll have been on Mars for about a month and a half. We'll be able to say, yes, we found organic material there. So in 1 year, call me back. Same number, call me back. And in 1 year, I hope to have some very interesting results to report.
We're looking forward to the next year podcast with you.
I imagine that if you found evidence of organics on Mars, then there's going to be quite a long list of people that are going to want to talk to you.
Yeah, that could be true. But just finding organics will not be proof of life, of course, but it's the first step. It's an important step. And if we find organics, I think it will galvanize interest in the search for life, and more missions will follow in rapid order.
There are different regions and climates on Mars. If you were going to look for life, or organics even, where would you start looking? What kind of regions of Mars would you look at?
Well, if I was designing the mission that would follow up on MSL, where I would send it to would be the polar regions. In fact, I would send it back to the same site that Phoenix landed at in north polar regions, about 70 degrees north, where we know that there's ground ice very close to the surface. Now, Phoenix had an arm and a scoop, but it couldn't dig into that ice. Ice-cemented ground is very hard, and so we need to develop a drill that can drill into that ice, get deep into it, and look for evidence of organics frozen into that ice. That's the mission that I would like to see next, and that's where I would like to go next, is this ice-cemented ground in the northern plains of Mars.
Do you think Mars will ever be terraformed?
Well, that's a really good question. Right now, we're asking the question, could it be? Could Mars be made into a place suitable for life? And when we say life, I think the first example of life we would like to consider is life that's on Mars, Martian life. It could very well be that Mars had life at one time, and that life is either retreated below the surface or is frozen and dormant or even dead. But even if it's dead, it may be possible to reconstruct the genome of that life. My hope would be that Mars had life, that it can be made life-rich once again, and that the life that would be there would be an indigenous, intrinsically different life, different from Earth life, a real second genesis of life, another planet. Imagine how interesting that would be to have a planet near us that's full of life and full of a different type of life. The scientific knowledge that we could gain from studying that life could be enormous and could have implications for many, many very practical things. If it turns out that Mars doesn't have life, then I would still argue that we should strive to see if we can make it a biologically rich planet. And then we would share life from Earth. So I think that we don't know if it's possible, but I think if it is possible, I would like to see Mars alive in the future, one way or another.
As would many of us, I think.
Yes. And from here, from Earth, you mentioned Atacama Desert and Antarctica and New Zealand. Is there any new learning from Earth that would make terraforming possible?
Well, the key question in terraforming is, when can life first start? And that's one thing we learned from these very cold, dry environments. Who is the toughest on Earth? And toughest means the ability to grow in very cold, very dry, very Mars-like environments. So one of the things, in a sense, that I'm doing when I go to these environments is I'm interviewing future Mars astronauts, microscopic algae and lichens. They will be the first Martians. So they don't answer the questions, but I'm observing them and interviewing them, so to speak. That's I think will be a very important day, the day the first organism lives on Mars directly in the environment, unassisted by a spacesuit or not enclosed. The first organism to live and grow and die on Mars in the nature. That's the first step. But we're also looking ahead to when Mars warms up a little further and more complicated organisms can grow there. And the key organism that makes a biosphere is a tree. That's the real engines of the biosphere, are trees. And so the next important milestone in making Mars habitable is, when can the first tree grow? And so we have been studying tree line on Earth, going to high mountains, particularly in the equatorial region of Earth, like Mexico. One of the highest tree lines on Earth is found in Pico de Orizaba in Mexico. So we've been going up there and studying what sets the elevation at which these trees grow, and how much warmer would Mars have to be before the equatorial regions of Mars were suitable for trees to grow, like the top of Orizaba in Mexico. That would be the second important milestone for life on Mars. First would be life, second would be trees.